So I'm Ravi Kumar Sahu, basically working in Vertiv Energy Private Limited. So today I'm taking care of what types of liquid cooling are available and what are the benefits and limitations, their adoption into the current data system and the way forward. So if you see the cooling density as from past to till now, so you can see the how this progression takes place. So earlier we used to have a 4-5 kilowatt racks we used to manage with the help of your perimeter cooling. Now then rack density is increased to 8 to 10 kilowatt, which we used to cater with the help of containment, with the help of false flow. Now when rack density increases, so maybe 15-20 kilowatt, we have introduced zero cooling based systems. So in that way we have come up to 50-60 kilowatt per rack. So these are the air cooling limitations. So 50-60 kilowatt cannot be possible with the help of air cooling only. So that is why liquid cooling comes in the picture. And this is not the new technology. We are using it from last 3-4 years. It's becoming a mainstream options for high density options. So if you see the servers, so basically whether it's air cooling or liquid cooling, how it differentiates. So we, as of now, we can see we have a categorization of air cooled servers and liquid cooled servers. So if you see all the server manufacturers or server OEMs have developed their self liquid servers as well. So you can see in this chart air cooling versus air cooled servers versus liquid cooled servers. So your space or you can reduce your space in terms of liquid cooling, and your power cost is also reducing. So this is one of the benefit where you can have more racks, more servers in the rack. You can get more space utilization as well as your power cost is also get reducing. So we'll try to understand how this cooling, whether we have a immersion cooling and direct to chip. Basically, these are the two basic types of liquid cooling as of now we are working right now. So how is it different? So if you see both are different technology, but the intention or objective is same. It's a high density computing and power consumption. So any servers which has fans, then it have fans and no fans. If it has a fans, then it is air cooled. We can say air cooled servers. We have to use air cooled cooling systems. If the system have no fans, then we can use it as a immersion cooling, and we can use it as a DCL, direct to chip also. So whether if it's a immersion cooling, then server has to be no fans, and if it's a direct to chip, then it may be a because in DCLC systems some of the components required your air cooling, so it has liquid as well as air cooling component in the servers. So if you see this is basically one of the demonstration of the liquid cooled servers. So so this we see these are the GPUs, CPUs, which is cooled by cold plate, and this is you can see the cold fluid, or you can say your glycol, which is coming into the servers, and this is inlet and outlet. So it has two component, liquid cool component and air cool component. So basically your GPUs, CPUs, which are high density, so this can be cooled by your cold plates, so that are liquid cool components, and your memory storage. These are the things which has to be cooled by your air cooling part. So you can say, as you see, it's a indirect to chip liquid cooling. Your air cooling percentage vary between 70 to 90% depending on the which type of servers you have. So this is about the liquid cool servers for DCLC, direct to chip liquid cooling. So now what are the components in the DCLC? So you can see it's has a main component is your CDU. Then it has a manifold. It has a cold plate. So these are the your secondary part of secondary system, which is inside the data centers. Then it has a heat rejection system. Heat rejection may be your air chillers or your outdoor units like condensers. So these are the liquid heat rejection systems. So as we discussed earlier, so we required a liquid as well as air cooling. So for air cooling, we can use your fan wall, you can use in your, we can use rear door heat exchanger. So whatever the your 80-20% or 70-30%. So whatever the air cooling component is there, we have to use either of the three-four mechanisms. So how this DCLC look like? So this is a row-based configuration where one CDU can serve some multiple racks. So you can see primary fluid network, which is nothing but your facilities water, maybe either from chillers or dry coolers, and secondary fluid network, which is your you can say technical fluid, or which is your glycol, which is going into the cold chain, cold plates. So this is also one of the configuration rack base. So here you can have a for each and every rack you can have a one CDUs. So this is called indoor CDUs. So this can be beneficial when let's say you are going to have 2 or 3 racks to be air cooled, or sorry, liquid cooled racks, and so this can be very useful when you are adopting from your air cooled data centers to liquid cooled. So this may be very small, easy, and can be retrofit easily into your conventional data centers. So this is your manifold. So manifold is a mechanism or pathway of how this cold fluids going into the cold plates and coming back into the. So this is one of the critical component, I can say. Designing of this system, your flow, your pressure inside this rack-based manifold is very critical. So from the design point of view, this is very critical because your flow and your temperature, your pressure, everything depends here. So this is, I can say, very critical part of this direct to chip liquid cooling. So talking about the benefit, so benefit of direct to chip is you can say this can be easily configurable to your existing data centers. You can use 2-3 racks. You can convert 2-3 racks into the liquid cool racks and can use it in your traditional or conventional data centers. So fan power. So since we have reduced your fan power 70 to 80%, so we can say your savings may be 20 to 30% in terms of overall power consumption. As we discuss, we can gradually transition to liquid. So if any customer wants to switch to a liquid cooling, so D2C is the best choice to start from. And since no dielectric fluid is involved, so cost wise, capital cost wise for cheaper. Limitation. So as we say, it has a rack manifold, row manifold, which is critical in design perspective. So if design is not proper, then it will not work. Leakage chances are very much more. So second is your CPU, and so this is means still you require air cool component. So you have to make provisions for either fan wall or your indoor cooling units or your RHX. So that is additional thing. Maintenance perspective, from maintenance, it is little big challenges, and and since coolant contamination is also some kind of risk is involved here. So now coming to immersion cooling, so we have seen direct to chip. So liquid immersion cooling is basically we submerge entire server into the liquid. You can see on the image. So basically, it has a tank. Each tank has a in the shape of in the size of 42U or 48U or 52U. So in that way, so either 2 tank or 3 tank or 4 tank, it can be based on the your rack density. So it has multiple tanks which is associated with one single CDUs, and this can be and heat rejection is through your dry coolers. So capacity wise, you can say any rack which has a higher capacity, let's say 80 kilowatt, more than 80 kilowatt to 180 or 200 kilowatt, this can so your immersion cooling will be the best choice based on the your heat densities. Yeah, so thank you. This is from my side.